Linux,
Okay.
Linux also. Okay, so we can start now. The Kubernetes.
Mhm.
So, you heard about the containers?
Yeah.
Okay, so because a container is also most important
Okay.
in before we started on the Kubernetes. So you have any idea about the containers?
Yeah, I think it's like a Docker containers like that, right? Like where we store our images or something like that.
Yes, yes, yes. So it's essential to have an understanding of container before getting started with a Kubernetes.
Yeah.
Containers are the executable software package containing all the codes and dependency necessary to run any application. So it's like we can run anywhere. If we are using the container, we can run that our application in any laptop, my laptop, your laptop, or even on the cloud.
Okay.
So, is are you heard about the virtual machines?
Yeah, like what do we say? Ubuntu, those kind of machines, right? Like VMs.
So, are containers starting to sound similar to the virtual machine?
Okay.
Well, they are not, and they are even better. Why? Because unlike the VMs, container do not contain the operating system. This
Okay.
means they are much more lightweight. So, if we talk about the virtual machine, so in the virtual machine, what is like there is a machine where we install the operating system. On the top of the operating system, we run our application.
Yep.
So, as we talk about the containers, so for the every operation, we can download the container and pull the image of that. It's like we are running the Apache. So for the we pull the Apache image and run the container for the Apache Tomcat. So if we want to run the MySQL, so we pull that image of the MySQL and run the container of the uh, Docker
Okay.
MySQL. So in this, we are not using the operating system. We are using the operating system of base OS of that machine.
Okay. So basically, the image should be already created somewhere, and then we
Huh.
are just pulling that one, and that will create a container around that particular image that we are going to pull. Is that how that works? Like, for example, in our organization, what we do is like we had a rancher desktop. I mean, we
Mhm.
use a rancher desktop usually.
Yes, yes, yes.
So we already had some images like database images. We'll just pull
Uh-huh.
those images,
Yes,
and
yes.
those images will be stored in this rancher desktop as a container.
Uh-huh. Yes, yes.
Okay.
So from that rancher images, we run that rancher image.
Yeah.
It's like the container or pods.
Okay.
In the Kubernetes, we run as a pods there.
Okay.
So pods is nothing, just like the set of the containers. In the
Okay.
pods, there are the two or more container will be there.
Okay. So for each pod, you are saying.
Yes.
Okay.
So okay. So where we are. Uh, the containers do not have the operating system images. So we just like use that. kernel of that OS. So the when we are running the Docker containers, we don't have the also the kernel of the specific. So it is lightweighted. So that's why it is more lightweighted to create and run the containers locally. You would use the container engine like Docker.
Okay. Okay. So basically, we just need like something like Docker engine or like Rancher desktop, those kind of third party applications we need in our systems or in our applications, so that then only we can run these pods and all that
Yes,
stuff. Yeah. Okay.
yes.
Okay.
So if we want to run the Docker containers, so we first need to install the Docker engine.
Okay. Yeah.
So Docker engine is able to run the Docker containers.
Okay. Got it. Yeah.
Okay, okay. And in the Kubernetes, there is for running the pods or containers, there is a container runtime environment is there.
Okay.
So that's we will cover later
Okay.
in
Sure.
the deeply. Yeah. So containers grew in the popularity because they are genuinely embraced in the ideology of write once and run anywhere, and because of how fast, easy it is deploy the container.
Okay.
So it will increase the developer productivity. S- Okay,
Yeah.
so then the Kubernetes will come like if we have more than 1,000 containers, so uh, it will hello,
Yeah.
there is a disturbance from your side.
Oh.
um, are you driving a car?
Yeah. But I'm not driving, so but yeah. But I'm side.
Okay,
I'll be there in 5 minutes. But yeah, I'm listening to you.
okay, no problem.
Yeah.
So if we run the multiple containers on any system, so um, so there is a difficult to manage that all the containers. So because if any containers will gets down, so in this case we are not able to manage that those containers. So it's like Kubernetes takes place on that. So Kubernetes is to manage the all the your application and our all the containers and pods if efficiently.
Okay, so basically, what we are the reason for the usage of Kubernetes is nothing but so if we run the containers alone, if one container is failing, so it will fail all other containers. But if we are running the pods, even though if there is a failure in one pod, the other pods will be keep running.
You can say about that, but I am just saying that if your application, if your containers gets down, so there is a way to there is a person who can start that container, so our application will be running. So
Okay.
there the Kubernetes comes. It will auto healing that our false container. It will automatically start our application. So Kubernetes will manage the scaling, deployment, all the things
Okay, so it's a kind of
in efficient way.
restarting the application, restarting the failed containers.
Yes. Now
Okay,
the Kubernetes does many more thing, but there is a one example of it.
got it, got it.
Okay. So Kubernetes is like you can say it called it about K8s. Have you heard about it? K8s?
Yes, I think I
Yes,
heard about this like K9s and K8s. So when we
yes,
run that one, we'll see how what pods were running and all the stuff, right? Yeah.
yes. So let's say you have a app, your app, and which have you containerized. So the run of the bunch of the containers to serve. your app to user. So these Kubernetes is to manage all the containers, and so we can start. So Kubernetes is a free and open source technology or automating the deployment, scaling, management, containerized application. As we already talked about that, it also being used a major cloud provider like Google, Microsoft, IBM, and Alibaba to run their container-based workload.
Okay.
So next slide we can. So Kubernetes was the first release in the 2014 by the Google, and the developer wanted to create a tool for the automating the deployment, scaling, and the management of containerized application. As we already talked, it is like it is a main tool for DevOps
Okay.
for automation, the deployment, scaling, and management of containerized application. So Kubernetes has become the one of the most open source project because its simplicity and easy integration with the cloud computing services. Okay, I already told about the containers and why we use containers. So we can go ahead. A container is a nothing but a virtual machine that is running on the single machine, and it is a just a virtual machine that has been configured to the provide a complete operating environment for your containers. So the container provides a complete operating system and all the application and libraries that are required to run a software application. So if you want to build a software application, you need to install the dependency in the containers, and if you want to run the application, then you need to install the container in the host. So it will the basic concept.
Okay.
So there is a features of the Kubernetes. So features of the Kubernetes like the on the automation, we can automate the process of the creating, deploying, and managing, and the monitoring the containers. So Kubernetes will allow the uh, all to handles our application. It's like when we are deploying that our application,
Mm-hmm.
it will manage the all the our loads, because load is like the traffic
Yeah.
it comes. Okay. So for the management of that application, we need the monitoring of that our application and monitoring of the pods also. So it will also provide the monitoring. Okay. So it's like there's the typical IT guy do that things. IT ops guy do that things. So Kubernetes alone the helps in that managing the our application. Got it?
Yeah, I think I missed some part in between. I don't know where it stopped. Hmm,
When it's like history of the Kubernetes,
oh no.
where
No, no, no. Right now in the slide which we are discussing right now, that slide itself. So we,
okay, okay,
yeah.
okay,
I
okay,
think the
I
first
can
point
repeat.
was done. I think from the second point. So that was missed, I believe. So
No, no, no. So I'm just saying that Kubernetes is like the IT ops guy.
okay,
So who can deploy your application, manage your application, and monitoring the your application like
okay,
the containers or pods.
got it.
So The when we are deploying the our application,
Mm-hmm.
so that after that we need to manage that our application, and the monitoring is also important part of the application for managing the application. So Kubernetes is all do the all work can do with the alone.
Okay.
Okay, so it is a complete package for
Mm-hmm.
to managing your application. So this allow the developers to focus on their primary task, which is the writing the code.
Okay.
So a developer only need to write the code, and Kubernetes does all the work for them.
Okay.
Okay, that's why Kubernetes is a more popular, is the most
Got.
popular nowadays. You can heard about the Kubernetes everywhere. This automation also allows the developer to scale their application as per need. So if we want, if the more traffic is coming
Mm-hmm.
from the outside network, more traffic is like the more user is using your application.
Okay. Mm-hmm.
So for this we need to scale our application as per the need.
Okay.
So we need to scale our the pods and nodes on that worker node, that Kubernetes nodes. So we can cover later. And the Kubernetes supports the many tools that make it easy for the developer to deploy, scale, and manage the application.
Okay.
Okay. So
So
scalability.
yeah,
Yes.
regarding the scalability, so you mentioned that we can reduce the traffic like by dividing them into different nodes or like that. So what that exactly means? For example, if I had an application,
Mm-hmm.
how exactly we can use this Kubernetes scalability into my application? Like generally, the process of running my application, if I had a code in my local, is that first I do
Mm-hmm.
a deployment in the sense I'll just create the jars like build. Once a build is done, so the jars will be created, and I'll make sure that those jars are deployed into my database properly. So for that one, I do have a deployment scripts or any
Yes.
command that to run, and then later I'll come back to my application. Right now we are using like a Tomcat, so we'll run that Apache Tomcat, and then that will run the application based on the database details that is going to return. Like in the configuration.properties, we'll give the database details, right? So based on that, it is getting started. So this is how my application starts. So if I want
Okay.
to do a scalability on this one, so what
Yes.
will be the
So there is a two type of scaling on the Kubernetes. One is like a horizontal scaling, and other is a vertical scaling.
okay?
Horizontal scaling is like we are increasing the number of replica. So it's like if we are using five container to run your application,
Mm-hmm.
we can increase it to the 10, 5 to 10, 5 to 6, 5 to 7. It depend on our choice.
Okay.
So we are increasing the number of replicas,
Okay.
and it's depend on the it's depend on the for the pods, and for the worker node also, number of the servers we are using, number of the nodes we will talk about the later.
Mhm. Okay.
In the Kubernetes there is a master node
Mm-hmm.
who are the manage the all the operation in the Kubernetes. And
Okay.
there is a worker node, there is a bunch of the worker nodes. uh, so their task is to run the pods on the worker nodes, and manage the pods in the particular worker nodes.
Okay.
So we can scale up the worker nodes also, the pods. In the application level we can increase the number of replicas of that pods, of that deployment or application deployment.
Okay. So basically, replica will say that how many nodes that we need to have for a particular pod.
Yeah, this
Okay.
is a horizontal scaling.
Okay.
And what's about the vertical scaling? In the vertical scaling, we just increase the CPU and memory. We increases the resource quota for the pods deployment, and also we can increase the resource quota for the nodes, worker nodes.
Okay.
Okay, so we can increase the CPU. If we are giving the CPU is like uh, five five core, so we can increase to 8 core. I'm just saying the
Yeah.
example.
Mm-hmm.
And we can increase the RAM to if we are giving the 10 MB, so we can increase the 12 MB. So it's like it is a vertical skill.
Okay.
I think that covers all the topic. And
Yeah.
so Kubernetes can easily the scaled up or down to the meet, or we can automate that process. Tejaswini?
Yeah.
Yeah. So in this, we are increasing the number of the replicas and we are increasing the resource quota. But we can automate it the process.
Okay.
When the number of nodes gets increasing, we can automate that process. Kubernetes having the feature of the automate scaling for that.
Okay.
Huh. So, the no need to require any man to increase that number of the containers or number of the resource increase the resource quota. It will automatically do that if uh, we allow them to increase the automation scaling.
Okay.
Okay, so Kubernetes can easily be scaled or scaled down to meet our the requirement of the cloud-based service provider. And the Kubernetes supports the horizontal.
Mm-hmm.
Kubernetes supports the horizontal scaling, which means that you can add more machine to a cluster to increase the number of the container. It's like we are adding more worker nodes to the cluster.
Okay.
Yeah. So the Kubernetes architecture is a highly scalable,
Mm-hmm.
and Kubernetes is a free. We all know about the Kubernetes open source project.
Yeah.
So is being used by the many cloud provider to run the container based workload. So Kubernetes is a free. So um, others cloud provider run as a service. Like Google is providing the service for Kubernetes, Azure also,
Mm-hmm.
and IBM also, and others many provider cloud provider.
Okay.
So 1 minute. So as it is a free tool, you do not having the for this the company have to not pay the licensing fees for
Okay.
this software. We can save a lot of money by using the free version of the that tool.
Okay.
But for running the managing the application as a free, the guy have to know the all the DevOps related because in the Kubernetes we need to set up the monitoring, and so guy having the knowledge of the that guy having the knowledge of the DevOps tool also, how the IT goes works.
Okay. So, you said like DevOps tools, right? So, which means is that just like a Docker or Rancher? I mean, it's just like a Docker engines or anything else other than this, like Jenkins or what exactly the other
Mm,
DevOps tools that we need to know?
so in a IT, we have a specific task on the operation. Just like if we need to uh, automate the deployment of the application in our organization. So so we can use the Jenkins for the CI/CD.
Mm-hmm.
So it's like a mm, we have just set up uh, we have just set up the process for the deployment. So that's need to if the application if the developer can commit on the Git, it will automatically deployed on the
Jenkins.
deployed the application. So this can be done from the help of the Jenkins. Okay.
Okay, yeah.
So
I'm
this is the one of the tool, and
okay.
for the automation purpose, for the automation we can use the Ansible and Terraform for the configuration purpose and automating our the daily needed task.
Okay.
And we can use the bash script for the automation task. Okay, so I think you are saying something.
Yeah, I mean, generally, it's like how we want to use it in our day-to-day IT works. Like, as you mentioned,
Yes.
it's just like if from the development point of view, once our development was done, and if it's working in
Hmm.
the local, we'll just push the changes into our GitHub or Bitbucket. So once
Hmm.
the changes were pushed, whatever that branch is there, like the master branch or a release branch,
Hmm.
so that will be
Hmm.
automatically triggered in the Jenkins. Like all the bells will be ran, and if there are like any automation tests or any unit tests which is,
Automatically
yeah,
deployment on the server.
server. So the Jenkins will
Yeah.
do that complete build and everything, and then they'll create a new jar or a zip file which is ready for whatever that. I mean, in our organization, it works in that way. So it depends on company to company. So whatever that Jenkins is doing, we need to have an idea how it is doing so that we can use the Kubernetes on top of that.
Yes, yes,
Okay.
yes.
So
And
this.
also for the for scanning of your testing of your build, there is a Sonar Cube is there. It's
Yeah.
also is it is also a DevOps tool, because DevOps is a vast area and
Yeah.
many tools are there for improving the process of the deployment.
Mm-hmm. Yes, that's right.
So Sonar Cube is there, and for storing the images, there is a Minayo S3 buckets. Many tools are there. So
Okay.
they are increasing the improving the process of the deployment. So DevOps task is only to improve the process of the deployment.
Okay.
Yes.
Yeah.
Any other question?
No, yeah, I think, yeah, it's what you were saying is just like we can use this Kubernetes on anything which is like auto developed, like even in the test cases, automation test cases also we can use this by, I think it's, you said like Ansible something. Yeah.
Yes. Yeah.
Okay.
So Ansible is like it is a configuration tool that's help to automate the configuration. Also, with the help of the Ansible, we can automate the task, daily need task to automate to reduce the reduce the efforts or the time.
Okay.
Okay,
Yeah.
so we can proceed.
Yeah, we can go. Yeah.
Okay. So Kubernetes is one of the most popular container management system available today. And the rise of the containers technology has increased the demand of the container within the organization. Because of this, the Kubernetes adoption is on the rise, and so is the demand for the Kubernetes security also.
Mm-hmm.
And for the example, the companies like Google, Netflix, and Amazon are using the Kubernetes. And in fact, the Kubernetes is the leading platform for the container orchestration and the management. As such as there are the tool to monitor you can use to monitor
Okay.
security, Kubernetes security, and there this these are the term. There is a term of orchestration.
Mm-hmm.
So, Kubernetes is an orchestration tool, and the term orchestration is used to manage the all the pods and all the application.
Okay.
Huh. So, orchestration is used here to manage the all the pods and all the operation running on the our server,
Okay.
our system. So, for the monitoring tool, and there is some tools for the Kubernetes. There is a number of the open source tools that you can use the monitor and the secure the Kubernetes. Here are the some most popular tools for the Happito Arc. Happito Arc is a cloud native monitoring solution for the Kubernetes. The Arc is built around the idea of the containers. As such, it monitors and reports on the container's health. The Arc also provides a number of the features to help you troubleshoot issues. So the Arc is the one of the most popular tools for the monitoring and securing the Kubernetes. So the Happito Arc is they are monitor the container's health. So
Okay.
it will provide the report of the container's health, and if the any alert will come, it will automatically identify to us there is alert for that. And New Relic is a commercial service that offers a lot of the features to help you troubleshoot issue with your Kubernetes deployment. New Relic can help you to monitor and the report the performance issues, and it is also like the it will help to monitor and performance issue can alert with a performance issue on our Kubernetes cluster. Okay, so these are the one of the most popular is like the Prometheus. Prometheus is an open source service for the monitoring and reporting on the Kubernetes. It provides a number of features that you can use the monitor and report on the. They all are for the monitoring and reporting purpose of the Kubernetes health and cluster health, application health. Okay, so these are the CloudWatch and Grafana, Alert Manager. They are all for the monitoring purpose.
Okay.
Okay.
So what
Uh,
exactly it is monitoring? Like I mean, you said like clusters, right? So which means the pods that we created, like for example, uh, I mean, I in a local, if you talk, I as I said, like in the earlier stage, I do have a deployment process in this way. So for that one,
mm-hmm.
I just created like couple of pods, like which
Mm-hmm.
is maybe, yeah, for the deployment pod is one of the pod, and maybe we to make sure the database up and running. So if I create like these two pods, so is
Mm-hmm.
that monitoring that part, like this CloudWatch or Grafana, whatever that is? So these monitoring tools are trying to see whether these pods are up and running, or whether these are healthy or not, or is
Yes,
this for
yes,
any other purpose?
yes, yes. So these monitoring tools, with the help of the monitor and the report of that our application,
Mm-hmm.
and it is also monitor and report the and for the our Kubernetes cluster also. And if anything goes not well on our application and our Kubernetes cluster, so it will gives us a alert, email alert, and also there is a SMS alert, so we can troubleshoot and resolve that issue quickly.
Okay. So like K9S or K8S, like
Hmm.
without using, I mean, generally we click on that K9S or maybe some kubectl command to see what
Mm-hmm.
pods were running, and like commands to see the logs, or like commands to see whether it's healthy
Yes,
or
yes,
not. So instead of
yes,
doing that, we are just keeping
yes.
a tool.
Monitoring.
Yeah,
Mm.
so that will
Is
obviously gives us like alerts, and we can go back and see what is it,
yes,
fix that. So it's
yes,
a similar
yes.
kind of
It's like a watchman. It's
okay,
like a watchman.
okay.
It's
So
like a
we
watchman, and they are monitoring our application and cluster health.
So these are inside like DevOps tools, like for example, along with
Yes.
like how we do with the Jenkins. We don't know what happens with the Jenkins, but once we push that one, it does it work, and if it works, it will go back, and if it fails, we'll get a alert. So in a similar way, these monitoring tools should be installed somewhere in the DevOps pipeline, or it should be in our local machines to do that one. Like
It should be installed in our Kubernetes cluster.
okay, in the cluster.
So Kubernetes is a powerful tool. It automatically monitor and report. So
Okay,
Kubernetes uses that kind of the tools in our in their cluster.
okay.
Yes.
Okay, it should be inside the cluster. Okay. So
Huh,
during our
yes.
initial setup itself, we can make sure that those tool, I mean,
Yes,
what the
yes.
tool is there, it should be there in the
Uh,
Kubernetes cluster.
yes, it
Okay.
should be there. It should be there.
Okay.
For if we securing and increasing our performance,
Mhm.
so we can use the other DevOps tool as well um, as it depends on the our requirement of the that application.
Okay.
So for easiness, we can use the other DevOps tools as per our requirement.
Okay.
Yes.
Okay.
These
Got
are
it.
the additional things, and Kubernetes already provide the monitoring and monitoring for the already providing the monitoring.
Okay.
Yes.
Yep. That makes sense.
Okay. Yeah. So there is a Commvault Kubernetes backups. So Vault, have you heard about? I think you already heard about the
And
vaults.
I mean, general vault you're saying, or the walls in the
Huh,
Kubernetes?
it's yeah, it's like a vault
Okay.
where we securing our
Yeah.
sensitive data.
Got you. Yeah.
So in this, one of the most ways to secure the Kubernetes cluster is to backup our data.
Mm-hmm.
Okay,
Okay.
so it is like the cluster data, cluster backup, okay, or our application backup, or it's like our application data backup, where the client information, application information.
Mm-hmm.
Okay, so Kubernetes is a highly available system, which means that it is not easy to recover your data if it is if a failure. So, for example, we are using the Kubernetes on the Google Cloud. You can use the Google Kubernetes engine to create the cluster. And if you are using the Kubernetes on the AWS, you can use the AWS Fargate service to create a cluster. And
Okay.
if you are on the using the public cloud, you can use the cloud backup to backup your Kubernetes cluster. However, if you are using the Kubernetes in own data center, then you can use the Commvault to backup your Kubernetes cluster.
Okay.
So they are saying that if we are using the cloud provider servers
Mm-hmm.
as a Google or Google or AWS, so they already providing to they are already backup our data, so we can restore from that. But when we are using the Kubernetes in our data own data center,
Mm-hmm.
when we installing the Kubernetes in our own setup, it's like our own environment. So then we can use the Commvault backup your our Kubernetes cluster. So
Okay.
we can use that Commvault vault to backup our Kubernetes cluster. Commvault is a open source product that is used to backup and restore our Kubernetes cluster. Okay.
Okay. Yeah.
So these are like to back up our Kubernetes cluster. So it's all the conclusion is like Kubernetes is a free and open source. It is being used by the many clouding to run their application, container-based workloads. And it is a free tool. You don't have to pay for the licensing fees of
Okay.
the software, and you can save a lot of money for using. So it's end up.
Okay.
Okay, so I'm just sharing the another slide
Okay.
regarding the how. So this is the Kubernetes architecture.
Okay.
So there is a master nodes and the worker nodes. There is a two worker nodes, but in our production environment, uh, there is a three master and some the number of the worker nodes depend on the our load of the application. So
Okay.
usually there are the 10 worker nodes, 8 worker nodes. So these depend on the our requirement. Okay.
Okay.
So these are the okay. So master is a managed responsible for the minimum running of the API scheduler cluster. Uh,
Mm-hmm.
so it's like so it's a first day. We can limit our things.
Yeah.
So I can you overview for the idea. It's like master is managed to all the operation activities on
Mm.
that Kubernetes cluster.
Okay.
Okay. So for the components of the master node, there is a cloud controller manager, kube controller manager, kube scheduler, kube proxy, and ATCD and kube API server.
Okay.
Okay.
Yeah.
And for the worker nodes, there is a kube proxy, container runtime, kubelet.
Okay.
So there is a kube API server. It will gives the interface to between the worker nodes and the master node. So the worker nodes can talk with the master node. So
Okay.
it will provide the communication between the master and worker nodes, the kube API server.
Okay.
And etcd stores the configuration backup, okay, in the key value pair. Okay.
Okay.
So etcd, it is a main brain of that Kubernetes master. It stores all the set of the configuration on the set of the configuration operation performed in the Kubernetes cluster.
Okay.
Okay. So there is a kube controller manage is used for the manage the all the operation on the Kubernetes. Okay.
Okay.
So these are the some important components, and kubelet is used for the responsible for the all the operation on the worker nodes.
Okay.
Okay. And kube proxy is like it its main operation is there ki when we expose a service
Mm-hmm.
to the outer network. So kube proxy is there to expose a service to outer network from the cluster. Okay.
Okay.
Okay. So I think it is very. I think that's sufficient for the first interaction.
Got you.
Yes. So any question about it?
Yeah, so far nothing. But maybe regarding the architecture, if I go forward, like I may get like couple of questions.
Yes. Yes.
Yeah. Yeah, I think nothing much right now for the basic understanding of why we are using the Kubernetes. But yeah, I do have still doubts like how we are going to
Yes.
install
Yes.
that and all the stuff. But yeah, maybe in the
Yes.
moving forward we can get to know more about this.
Yes. Yes.
Uh,
It
yeah,
will cover on the our
gotcha.
later class. Okay. And so time will be same, na?
Yeah,
6:30
mostly.
in IST. Yeah.
Yeah, mostly I was preferring for this timing only because it's bit feasible for me. Um,
Mm-hmm.
but on weekends I will let you know. But yeah, it depends. Like if you are available in your evenings, then I can connect in the morning of my Saturday or Sundays.
Okay.
But yeah, I'll let you know those timings also. But I figured like it should be like somewhere around 9 to 11, which would be around like 6:30 to 7 or 8 in your evenings of Saturday, Sundays. But yeah, I'll let you know about that. But it's not
Yeah,
like,
we can discuss later
yeah.
about that. Yes. So, how much experience you have?
Uh, and this one, I don't have anything.
No,
Uh,
no, in IT, in development.
oh, just like 2 years, I was
Okay.
started working on this one and just like basic Java developer.
Mm-hmm.
Yeah. So initially, when I started, I worked with this Kubernetes a bit, but I don't know anything, any clue of this one at that point, because we used to already have some .yaml files. They said that we need to
Yes,
copy
yes.
that for the different pods, and you just need to run that Helm commands. So there is a
Mm-hmm.
bunch of predefined commands that they had given. So I just used that one, but I don't know what exactly that is doing. But
Yeah.
in my current project, it's like becoming like a mandatory stuff. So
Hmm.
just
That's
want to,
things we will cover on the later classes, and
yeah.
all things will be cover. We will cover.
Okay. Yeah. So just want to make sure. So, and also, I don't know if I want to change this to DevOps. I mean, I don't know if this coding will be like a little bit, I mean, you know how the Java works and all the stuff. So I'm not
Yes,
a
yes.
pro in those codings and all the stuff. So maybe if the certifications were there in future, I can convert to in a
Yes,
DevOps
yes.
side.
We
So
will help you. We will help you about that. If you want to convert it to transition with DevOps, so we can help you
okay.
for
Yeah.
the transition in the DevOps.
Yeah.
So
That.
DevOps is a vast field, but no worries. It will be done.
Okay.
Yeah.
Yeah. That makes
So
sense.
yeah. So for the DevOps, the Kubernetes is most important.
Yeah. So
Yes.
yeah, so it's basically Kubernetes is nothing but a kind of uh, dividing our work into chunks. That's it, right? I mean,
Yes, yes.
whatever that.
Because it's like they are providing the platform where we can deploy, monitor, manage,
Got you.
automate that all the things.
Okay, so how hard is
Yes.
this exam, like CK, like general certification stuff that we are discussing? So if we know just like the basics, that would be enough. Just I mean, how the exam will be like only multiple choice, or there's anything that is related to a bit of coding.
Some of the multiple, actually, it is a practical based exam.
Okay.
So where you can also practice about the you have to build a application. You have just you need to configure the ingress and any most more the things we can discuss later.
Okay.
But if your requirement is to only deploy the application, then you can pursue that training purpose. No? Our
Okay.
yeah. So the examination is a later thing.
Okay,
First, you need to just learn about the how the Kubernetes is working.
got you. So yeah,
We
right
can
now.
discuss later about the training, the certification
Okay,
part.
yeah. So
I
for
will
now,
assist you
yeah,
about that.
got you. I mean, generally in my company right now, what we were doing with this Kubernetes or like the what we say the files that we are writing, so it's generally basically just like .yaml files, and
Yes,
then
yes,
we just give the names like what we say, we create each configuration files like
yes,
config
yes,
map.yaml files like entry points, and we define all those values in the local
yes, yes.
values file, something like that. Yeah, I know a little bit like small things like that too. It's a Google
Mm-hmm.
knowledge, nothing special in
Mm-hmm.
that I learned, just to write
Mm-hmm.
what should be there in the YAML files and like maybe creating a secrets and all those stuff. So that we
Yes,
had done, but I don't know how it is working, so that's the reason I just want to learn more.
yes, yes.
Okay, yeah, I think we can discuss more at the upcoming classes. For today, I think I got like bit of information and which is useful for me right now. So yeah,
Okay, okay. We can discuss the later on the
yeah,
later. Okay. So can you join tomorrow as well on the
yeah,
same time?
yeah, sure. I'll just discuss with Pawan one more time, and just finalize all the things, and I'll let you know all the timings.
Okay,
Most
okay,
probably, yeah, the same timings.
okay. Sure,
Yeah, sure. Okay.
sure. Thank you so much.
Thank you, Devendra. Bye.
Yeah, thank you. Thanks for came there.
Okay, okay, okay. Can I leave this
Sure,
meeting?
sure. Yep.
Okay. Thank you. Thank you so
Yep.
much.
Thank you.
Thank
Bye.
you, Tejaswini. Thank you, Pawan.